Hello and welcome to section 2.1b. This is quadratic functions again. What I would like, I'd like to start with saying that as you watch these videos, if you have any questions, please mark the examples so that you can come in and ask the question that you don't understand. Then it'll just make life easier for you guys if you come in and ask your questions. So today we're going to say what happens if we have we want to find the vertex of a quadratic that's not in standard form. Well, what we have to do is we have to complete the square. And you may remember this from Algebra 2. And so what we end up doing with this, well, let's go through and do this problem. This is similar to the example that I used the other day. But first thing that we do is we deal with, we can't have, if we can get into vertex form without completing the square, well, actually we have to complete the square pretty much all the time, but where this one is tricky is that we have a variable, a number in front of the x squared. So the first thing I have to do is factor out that number. And so I get x squared plus 4x, and I'm not even going to bother with the 7 because if you remember completing the square, this number out here doesn't really have much consequence. I mean, it does, but in the completing the square idea, it doesn't factor in right at the moment. So what I'm going to do is I'm going to start with the middle term, the x term, and divide that by 2. And whatever, I get 2 when I do that. And then I square that number, and that's the number that I'm going to add and subtract from this problem. Well, the issue is that this 4, the red 4 that I just put in there, is going to be multiplied by the 2, so I have to keep track that I multiplied by 2. It's really an 8, and this number out here also needs to be an 8. So in completing the square, when we have something that we factor out, make sure that you multiply what you add and subtract by that 2. And this 4 that's on the inside will get multiplied by 2. So it's just dealing with the outside one. And the reason we add and subtract is just like when we're solving an algebra problem. We don't want to change the problem any. We always do the opposite to get rid of something. Well, if I add 8 and subtract 8, that's going to be 0, so it doesn't change my problem any. So continuing on with this problem then, I can factor the inside of this, that it will factor nice and neat, and actually it'll factor nice and neat. The 2 will remain out front, and inside, when I factor this, I get x plus 2 squared. And then on the outside here, when I take 8, negative 8, and add it to my 7, I get negative 1. So now I'm in vertex form. So now this function is in vertex form. So my vertex in this case is going to be, well, the inside, the opposite of the inside is x, which is negative 2, and exactly what I see on the outside is my y value for my vertex. Remember that vertex form of a parabola is y equals a times x minus h squared plus k. And so the h and the k are the vertex, and you'll notice that the inside is the opposite and the outside is exactly as we see it. So then line of symmetry, you remember, is just the x value of the vertex, and so that means that it is x equals negative 2 is my line of symmetry. So we'll try completing the square one more time on this guy up here. You'll notice that there's still a number out in front of my x squared, which happens to be negative 1. So negative 1 times x squared, I'm just factoring it out, so it changes the sign on the 5x. I'm going to leave the negative 4 alone, and I'll deal with that in a little bit. So again, I have to take the middle term, which is negative 5, and you keep the sign, divide it by 2, and that's the best I'm going to get. So then I'm just going to square that number, which gives me 25 over 4. And so that's the number that I add and subtract. So I'm going to add 25 over 4, and I'm going to subtract 25 over 4. But you might be saying, wait, what about that negative 1 out front? So that 25 over 4 inside gets multiplied by negative 1. So this guy over here also needs to get multiplied by the negative 1. So with a little simplification, the factoring of the inside. Now, you may be freaking out and going, oh my gosh, this factoring is going to be horrible with 25 over 4. Well, one thing that you'll notice that if you look back to the previous problem, when I factor the inside, when I take x plus 2 times x plus 2, the number that I got when I divided by 2, when I took the middle term and divided by 2, that's actually the number that I factor out to be. So you'll notice that if you keep the sign, I have a negative 5 halves, so this becomes x minus 5 halves. And if you don't believe me, FOIL this out, or use the box method and multiply this out, x minus 5 halves times x minus 5 halves, and you'll see you'll get this last term. It should all work out. And then over here, well, this is where it kind of gets ugly. So I'm going to have minus 4 and then plus 25 fourths. So in order to get the vertex, I'm going to have to combine these. And right now, this negative 4 is over 1. So I have to multiply the top and bottom by 1 of this number. And the one I'm choosing is 4 over 4. Because if I take 4 over 4, well, that gives me a common denominator so I can add these fractions together. And also, it will end up giving me the give me what I'm looking for to combine my like terms on this, and which will give me my y value for my vertex. So I end up with x minus 5 halves squared, and then if I multiply by 4 here, I get negative 16 over 4 plus 25 over 4, which then combining these guys together will give me my final answer. Well, it's not even my final answer because it's just getting me into vertex form. I haven't even picked out the vertex yet. So I've got negative 1 times x minus 5 halves squared, and then combining these guys together, I get negative 9 over 4. Actually, positive 9 over 4. You're probably, I didn't, anyway, positive 9 over 4. So vertex of this guy, take the opposite of the x value, which is a negative 5 halves, which becomes a positive 5 halves, and then take the value outside, which is 9 over 4. So there's my vertex. And then my axis, or my line of symmetry, sometimes it's called an axis of symmetry. We're using line of symmetry. So my line of symmetry is, again, just the y value on my vertex, which is 5 halves. So just a reminder of how to complete the square. You might want to rewind and watch this a couple times because this is a challenge, and this is something that we need to know how to do. So moving along, so we're going to identify the x-intercepts. And so the question is, what are x-intercepts? Well, remember, all of these guys are parabolas. And so, because they're all x squared, and so we're trying to figure out whether, if, like in the first one, if it goes upside down, where it's crossing the x-axis, those would be my x-intercepts, and or if the parabola goes the other way, if it comes down and where it might cross the x-axis. So that's what we're looking for. And so we can do this by factoring. We'll try this one by factoring. First thing I'm going to do is factor out a negative 1 to get rid of the negative in front of the x squared. That'll make my factoring life much easier, hopefully. And so I get something that looks like that. So then, if you like, you can say, okay, well, I have 8 and negative 6 down here. And so the only way I can get 8 and negative 6 is negative 4 and negative 2. So those guys will multiply together to get me positive 8 and add together to get me negative 6. So if I do that, I say, okay, negative 1 times x minus 4 times x minus 2 is basically equal to f of x, but then I'm going to set it equal to 0 because that, remember, f of x is the y value. So when I set that equal to 0, I'm finding out where it's crossing the x-axis. Well, zero product property means that if I can make this 0, this thing will all equal 0, and so I need to find the value that will do that. So what I can do is a quick little algebra problem. Say, what will make this parenthesis 0? Well, if I add 4 across equal sign, x is 4. There's one x-intercept. Or the other option is, what would make this guy 0? And so I take x minus 2 and set it equal to 0, and so then x is 2. And so these are the x-intercepts, 4 and 2. Kind of looks like, well, it's probably going to be upside down, but this graph would be shifted over. So then, down here, they want us to use the quadratic formula. And so the quadratic formula, remember, gives us our x values, and it is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now this doesn't mean that this thing isn't factorable or something like that, but right now this is the way they want us to do it, so this is what directions we're going to follow. And so we need to remember what a, b, and c are. Hopefully you remember a is the number in front of x squared, b is the number in front of x, and c is the number that's the constant. And remember, you got to take signs with it too. So b is positive 5, so I'm going to say negative 5, the opposite of 5, plus or minus the square root of 5 squared. I'm just going to square 5 because I can do that. And then minus 4 times a, which is 2, and c, which is negative 3. All of this guy is going to get divided by 2 times a. Well, with a little bit of simplification in this, x is going to equal negative 5 plus or minus, and it looks like, let's see, I've got 25, and 8 times 3 is 24, and it's positive, so I add 24, all divided by 4. And so I'm going to kind of move up here for lack of space, and so x will equal negative 5 plus or minus the square root. If I add those guys together, I believe that's 49 over 4, and so x will equal negative 5 plus 7 divided by 4. That's the square root of 49. And the other option is x will equal negative 5 minus 7 over 4. Well, negative 5 plus 7 is 2 over 4, which will give me a half. So there's one x value. And the other one is negative 12 over 4, which will give me negative 3. So those are the two places where the graph is crossing the x-axis. And then the last one, they want me to do this with a graph, so I'll grab my graphing calculator here and graph it. And so I've got 4x squared plus 25x minus 21, and I have a feeling, well, partly because of the minus 21, I'm not going to see all this graph. There it is, yeah. If I could zoom out to see the bottom of the parabola, and actually I'm going to change my window just to include that number. So we'll go 25 on my minimum, negative 25 on my minimum, and you'll see the bottom of the graph then. Oh, nope, it's way down there. I guess I was, oh, 21 is where it's crossing the x-axis, so, or the y-axis, so I'm not going to bother looking for the bottom of it. But hopefully you can see, if I zoom way out, you can see it, but I'm not going to bother because I don't need it. I only need these guys right here. So if I want to do it graphically, I can just go ahead and say, okay, well, I'm going to do my second calculate, and I want to find a 0 of the function. That's the solution. That's another name for a solution. So what I need to do is I'm going to arrow, and I need to be, in this case, I need to be below what I think is the 0, and then I need to be above, and then I need a guess at it. And so one of them tells me when y is 0, x is 3/4 or 0.75. I like fractions over decimals, so if I can use a fraction, I'm going to use a fraction. So then I'm going to try the next one and do, so we said that x was 3/4. And so now, alright, so now if I go back and do the 0 for the other one, we're just going to have to remember that it was 3/4. I got to arrow over to it. See if my cursor comes back here. I'm looking, see my cursor's down here in the negatives, so now it's getting more positive. So I got to go above it. Oops, no I don't. I messed it up. Oh well, we'll do it backwards. Below it. Oh no, that'll work. And there it is. So this time it's saying it's at -7. So my solution to this problem by using the graphing calculator, by doing the 0, was x was either 3/4 or x was -7. And so those were my two solutions, and that's how you do it graphically. You can just use the 0 function of the calculator. So then if we want to find two equations for the quadratic, there's probably more, but we're going to go ahead and use these two to find the x, given these x-intercepts. So what I'm going to do, well, I know that so to find the equation, we're just going to find, since these are the zeros of our function, we're just looking at the x values. That's really all we need. And remember that at some point in time, they were written as this was what x is equal to, so x equals 0 and x equals 10. That's one way we wrote them. And if I kind of work backwards algebraically, which seems kind of counterintuitive, I'm going to subtract 0 from both sides, so I get x minus 0 equals 0. And over here, if I subtract 10 from both sides, I get x minus 10 equals 0. So this x minus 0 and the x minus 10 are our two functions that will the two binomials that will multiply together to get me the quadratic function that I'm looking for. And really, I could just write it as x times x minus 10, because of the 0 minus 0 doesn't really help me. So if I multiply these guys together, now you have to understand that in this, there should be y equals a. There's going to be some multiplier that's going to either make the thing steeper, narrow, compress it, whatever. And so this is the way we always start. So there's an a being multiplied by the x minus 0, so I'm just going to put an a here. And so y will equal a times x squared. And I'm just going to multiply these guys together and then minus 10x and leave the a as part of the problem. So basically what I did, I'll go back up here, is I multiplied these guys together. I said a is x times x minus 10. Multiplied the x times both terms and left the a out of the problem. So I got x squared minus 10x, and then now this a value is the compression value, or the stretch value. And so there are multiple solutions because we don't know anything else. We need to know an x and a y, another point besides these guys on the function to find the actual a value. So that's why he said there's more than one solution. And so my solution, one version would be this to open up. That would open up, and then the other version would be y equals a negative a times x squared minus 10x, and that would be my way to open it down. And so that's really all we're looking at to get this. And so without another point on the graph, on the function, we're not going to be able to get what exactly a is. So then finally, our final problem is we want to find a baseball that's hit 3 feet above the ground. So I'm going to draw a little picture down here. I got a little guy that's going to hit the ball, and he's got a bat. So he hits the ball 3 feet above the ground. So this is 3, the distance to the ground. And then he hits the ball like that out into the outfield or something like that. And so that's what he's trying to do. He's going to hit this ball. And so you may notice the way the arc of the ball is that this thing is a parabola, and you could also see it by that. And the 45-degree angle, 100 feet per second, is really not any consequence. It's already taken care of in the equation that we were given. So to find the maximum height, we want to find how far up in the air it is. And you may notice that if I draw kind of like that, to get that maximum height, what is that? Where is that maximum height? Well, that would be the h and the k of the parabola. And we'd have to add 3 feet to the to the k value to actually find the maximum height, because the parabola going from 3 feet above the ground to 3 feet above the ground would be the way the parabola would work. So to find our h value, to find our h value, or our h and k value, we're going to take this guy, and I'm actually going to graph it. That's going to be our best plan of attack. And so if we graph this thing, we will find out, we could just find the maximum using the graphing calculator. So -0.0032 x squared plus x plus 3. And actually, by having that plus 3 in there, that's already taken care of the height. And you can see that my parabola, so I'm going to do a zoom fit and see what that does for me, see if that helps me at all. Nope, didn't help me at all. I'm going to zoom out then. And I may have to keep hitting enter a few times till the parabola, well, that didn't help me either. Let's do zoom 6. Let's go back to standard. And then do zoom out a bunch of times until I kind of see the parabola. Okay, so there's the parabola. And so now I need to find the maximum of that. So I'm going to do a second to calculate and use the maximum value, which is 4. And so now I just need to go to the left of the what I think the maximum is, to the right of what I think the maximum is, and then, because I'm not going to complete the square on this. So the ball is at a maximum height for A is 156.25 feet. So the height of the ball, K, oh wait, I did that wrong. Hold on. Isn't that? The height of the ball was 81.125 feet. So the Y value would be the height at the maximum. So 81.125 feet. So the maximum height for A was 81.125 feet above the ground. And so then for B, what was the maximum horizontal distance the ball traveled? Well, that would be the distance from here, from 0, 0, all the way out to wherever the ball lands. And basically, we need to find out where this function right here is equal to 3, because it was 3 feet off the ground. So I'm trying to find out what the maximum horizontal distance is. And well, actually, I'm just going to find out where it crosses the x-axis, and we'll be good there. So that's what we were talking about before. And so if I go ahead and find the 0 function of it way out here, above and below, and then try to make a guess. And so its maximum distance is 315 feet. So the maximum distance that I have for B was 315 feet, and it had some change on it. I didn't get that, but I think it was like 2.5. 315 feet, and then is the ball hit a home run if the fence is 330 feet away? No, because the maximum distance was only 315 feet. So no is the answer to that one. So this concludes all the examples for 2.1b, quadratic functions. If you have any questions, again, please watch them again, and please come to class with those. Thank you.